everybody, I wanted to give you a real quick rundown on some of the stuff I want you to know related to the last few sections for the checkpoint tomorrow. Or for the future if you're reviewing for the test. Who knows? Anyway, so if I ask about the key features of a polynomials graph, there's really three things that I'm looking for, which are in particular the x-intercepts, the y-intercepts, and the overall shape of the function. Okay. Now, one of those things, the x-intercepts, also known as the zeros, it's easiest to find those in standard form. For the y-intercept and for the general shape, probably standard form is going to work better for us. So let's try it with an example. I have f of x equals x plus 2 times x minus 6. That's in factored form right now because it's got the two factors, the two things in parentheses, okay? Because I'm going to need it eventually, I'm going to go ahead and get standard form for this function. So let me multiply things out. I've set up an expansion box. Remember, this is just a fancy way of representing distribution. You take each term in the first group times each term in the second group. So if I take x times x, that is, of course, x squared. If I take x times 2, that's 2x. Negative 6 times x, on the other hand, will be negative 6x. And lastly, negative 6 times 2 will be negative 12. If I put those terms together, the like terms in particular, I could write this as x squared minus 4x minus 12, all things said and done. That's standard form. Now that I've got in standard form, let's go back and look for some of these things. What are the x-intercepts? Well, the x-intercepts are related to the factor form, as I said, and what I remember is that the x-intercepts are the places where each of the factors is equal to 0. So what values of x make my function equal 0? Well, I know that would be negative 2 and positive 6. Okay, so negative 2 and positive 6 are the x-intercepts. Because if I put either of those numbers in for x, then the entire thing turns into 0. If one of the factors equals 0, then the entire product is 0. That's called the zero product property. Okay, so those are the x-intercepts. What about the y-intercept? Well, we have discussed that the y-intercept is always equal to your constant term. That's the number with no variables on it when it's in standard form. So the y-intercept, there's just one of them always, is going to be negative 12 in this case. And as far as the overall shape of this graph, that's related to the degree of our polynomial, which is what is the highest exponent that you see on a variable. And in this case, I would say that this is a degree 2 polynomial, which means that its shape is going to be a parabola. Okay, it's a U-shaped curve if the highest degree is 2. Okay, could I take those things and graph my polynomial? I could try. Sure, why not? So here's going to be my very rough sketch. I don't know. We'll see how this works out in practice. Okay, so here's my little coordinate plane. Okay, I'm going to put on my x-intercepts at roughly, here's my negative 2. And then I'm going to put on another one at positive 6. I know that my U-shaped curve has to pass through those points, as well as the y-intercept, which I wish I had gone down a little bit lower here, but I'm going to call this negative 12. It's probably a little bit lower in practice, but whatever. We're going to call that negative 12. And then I should make a U-shaped curve that goes through those 3 points. And so here I go. Whoa! This is pretty rough with a mouse, but that's very roughly speaking what the graph should look like. U-shaped curve passing through the x and y intercepts. Sure. Okay, let's try it again, but with a slightly more complicated function. This one, g of x equals x plus 2 times x minus 6 times x minus 1. Now, if some of that looks familiar, it's because I planned it that way. These two terms, x plus 2 times x minus 6, that's what we had in our first polynomial on the previous page. Okay, so I already know what happens when I multiply those two together. It makes x squared minus 4x minus 12. So if I'm trying to get that in standard form, now I just need to multiply my result there by x minus 1. And so I will. So I will take the result of the first two terms and then multiply that by x minus 1. Let's see how that goes. X times x squared is x to the third. X times negative 4x would be negative 4x squared. X times negative 12 would be negative 12x. And we're done with the first row. Then negative 1 times everything. Well, that's easy enough. Negative 1 times x squared is negative x squared. Negative 1 times negative 4x will be positive 4x. Negative times negative is positive. And likewise, we'll have 12 on the end here. I write that in standard form. Just again, make sure you're combining the like terms, which are the negative x squared and the negative 4x squared, as well as 4x with negative 12x. The simplified version then, in standard form, would be, let's see, x to the third all by itself, negative 5x squared. Then, let's see here, positive 4x and negative 12x would make negative 8x, and plus 12 on the end. Wow, standard form. Okay. Now that I've got standard form, again, let's identify our key features. What are the x-intercepts? Well, two of them should be the same as before, right? Should be negative 2 as well as positive 6, but joining us now would be 1, okay? Because that's the value for x that will make this third factor equal to 0. And again, if one factor equals 0, then the whole thing multiplies to make 0, right? That's the zero product property again. Meanwhile, the y-intercept, I will look at the standard form for that, and we can say that the y-intercept is the constant term. Now it's positive 12, okay? So y-intercept at positive 12. And when we go to talk about the shape of the graph, we're going to think about the highest degree term, which is x to the 3, highest exponent. So if it is a degree 3 equation, we know that every degree 3 equation has an overall n-shaped curve. So something kind of like, something like that. I don't know why I was trying to draw over here before. I know I can draw anywhere I want, right? So I'm going to make a little graph of this, okay? So here I go. I'm going to make an x and y coordinate plane, and then try and graph this a little bit, okay? Let's make sure that all of our intercepts are represented. So intercept at negative 2. Let's make it a different color. Okay, here's negative 2, and then positive 1, and positive 6. And then my y-intercept is up at positive 12. I feel like that should be a little higher. Let's go up a little higher here. Oh boy, this is rough. But I'm doing it anyway. So here I go. Here's my y-intercept at positive 12. And then again, this was, what are those? Negative 2, positive 1, and positive 6. Okay. And I know it should be an n-shaped curve that goes through all of those points that we just listed. And so here I go again. Sorry, my mouse. This is going to make it really rough, but I know it's got to be an N shape going through all those points. Something like that. Something like that. If I was doing this with pen and paper, it'd be a lot smoother, but I know it is an N-shaped curve passing through all of those points that we just identified. Hope that helps. Let me know if you have questions.